All right, so example 1, we're going to look at this function, sort of a crazy piecewise function, and talk about where this function is and is not differentiable. So where can I not take the derivative of f? We are going to practice referring to the definition of differentiability. So one fast one I'm going to let you answer fast. And that's, there's something going on at x equals -1. So I'm going to say at x equals -1. Oh, this up here, I just copied down that definition of where a function f is differentiable at a, when a function f is differentiable at a. So we can remember and refer to it. So notice x equals -1. This here, it seems to me like a vertical asymptote. I think there are implied arrows here and here. I think no matter what you do, there's no y value when x equals -1. So I think this function f is not defined at x equals -1. So I'm going to say at x equals -1, f is not differentiable. I guess I could have used the text tool. Because f of -1 is not defined. And that's a big idea that we have to know. It doesn't come up a lot, but you can't try to take the derivative of a function f at a point that is not in its domain. So at x equals -1, if f is not defined, then by definition, f prime is not defined. Let's try this next one. The next place that something funny seems to be happening is at where x equals 0. To the left of -1, that function seems smooth and continuous. There's no bumps or gaps or anything, any like pointy things, cusps or corners. So I think to the left of -1, f is differentiable. In between -1 and 0, it seems differentiable to me. There's something funny at x equals 0, though. So I'm going to say at x equals 0, f is not differentiable because, that's BC for because. Watch what happens when I try to take the limit as x goes to 0 of f of x minus f of a over x minus a. It's going to be the limit as x goes to a, for example, from the left, of f of x. Sorry. I decided that we're investigating the place where x equals 0. So this would be the limit as x goes to 0 of f of x minus f of 0 over x minus 0. I could write the other half of this equation and investigate the limit from the right, but watch what happens when I finish investigating this limit from the left. It's like the limit as x goes to 0 of f of x minus, look at what f of 0 is. So f is defined at 0, so I'm not off the hook the way I was at x equals -1, where I said, hey, if f's not defined, the derivative is for sure not defined. But f of 0, for discussion, it's not marked, but let's say that's 1.5. Now I can think about what happens here. If I take the limit as x goes to 0 of f of x, well, I can follow that along. As x goes towards 0, f of x approaches 2. This is going to be 2 minus 1.5 over 0, which is not defined, but nor is it an indeterminate form. And remember, we can only continue to investigate a limit problem if I have a 0 over 0 problem, or some other indeterminate forms we're going to talk about in chapter 9. But 0.5 over 0 is not indeterminate. 0.5 over 0 is undefined, and this limit is now undefined. So the limit as x approaches 0, I didn't specify, but I was thinking about 0 from the left, is undefined. So is it going to equal the limit from the right? No. So the limit has to exist before it can equal some other limit. So since the limit as x approaches 0 from the left of f of x minus f of a or f of x minus f of 0 over x minus 0 is undefined, then this whole limit is undefined, which means these two sides are not equal, which means f is not differentiable at x equals 0. Let's try the next one. The next place something interesting seems to happen is at x equals 1. So I'm going to investigate the limit as x approaches 1 from the left of f of x minus f of 1 over x minus 1. And I'm going to decide, I'm going to put a question mark there saying, I'm trying to decide if these two things are equal. The limit as x approaches 1 from the right of f of x minus f of 1 over x minus 1. So remember the definition for when a function f is differentiable at a has an a in it. But now I'm focusing in on these specific input values. In this case, I'm investigating where x equals 1. It's my job to replace all the a's with 1s. So the limit as x goes to 1 from the left of f of x minus f of 1 over x minus 1. I'm supposed to get something that's equal to that slope. I see now, I didn't mark these. I repurposed this picture from another problem. But I could do that, so that's going to be like... All right, so watch what happens. As I approach 1 from the left, that means I'm coming from this direction. That means the x values are less than 1, which means in the denominator, when I subtract x minus 1, I'm going to have a number less than 1, and I'm going to take 1 away. That denominator is going to end up being negative. And watch what happens here. F of x minus f of 1. Well, f of 1, I know, just for discussion, we could say it's 3. To the left of 1, the y's are all less than 3 because they're going uphill toward 3. So this denominator, this numerator is also going to be negative. So maybe I don't know an exact value, but I can tell that from the left, the derivative is a negative over a negative, so it's going to be positive. From the right, my x's are bigger than 1, so in my denominator, this is going to be the limit as x goes to 1 from the right. My denominator is going to be a number bigger than 1, take away 1, which is positive. And my y values are all less than 3. So, and I'm going to be subtracting f of x minus 3. So smaller than 3 minus 3, this is going to be negative. So that limit is going to be negative. My question is the positive slope from the left going to equal the negative slope from the right? Well, these can't possibly be equal. So I'm going to say f is not, how about I type it up? So this is what I would write. I would say f is not differentiable at x equals 1 because, and I would write this out, the limit as x approaches a from the left of, not a. I reminded you earlier to make sure you plug in the a because I forget to plug in the a. So as x approaches 1 of f of x minus f of 1 over x minus 1 is not equal to the limit as x approaches 1. This should be from the left. This is, well, if that's from the right, then this can be from the left. F of x minus f of 1 over x minus 1. Final answer for what happens at x equals a, at x equals 1. All right, so one last one. We have this problem at x equals 2. I can tell there's a discontinuity. I kind of have in my mind this informal idea that I can't take the derivative of f at a place where it is not continuous. But let's prove it. So I'm going to say at x equals 2, I want to know if the limit as x approaches 2 from the left of f of x minus f of 2 over x minus 2 is going to equal, question mark, limit as x goes to 2 from the right, f of x minus f of 2 over x minus 2. if I can show that one of these doesn't exist, then I can be finished, right? So let me try this. What if I approach from the right? The limit as x goes to 2 from the right of f of x minus, what's f of 2? 2 is 2, all the way up there, over x minus 2. This is the limit as x approaches 2 from the right. As x approaches 2 from the right, f of x is approaching 1. I'm going to have this problem again where this is going to be 1 minus 2 over x minus 2, the limit as x goes to 2 from the right. I'm going to have a negative 1 in the numerator and a 0 in the denominator. That is not an indeterminate form. That means that this limit is actually undefined because I have a real regular number, negative 1, divided by 0. So if the limit as x goes to 2 from the right of f of x does not exist, then it can't be equal to the limit from the left. So I would say that f is not differentiable at x equals 2 because the limit as x approaches 2 from the right of f of x minus f of 2 over x minus 2 does not exist. Now, so we've tried to find the limit from the left as we approach 2. This limit actually does exist, but because I'm going to have that f of x minus f of 2 over x minus 2, and that limit as x goes to 2 from the right, f of 2 is approaching, f of x is approaching f of 2. So I'm going to have a 0 over 0 as I check out from the left-hand direction. But my right-hand limit does not exist, which means that these two sides cannot be equal, and so f is not differentiable.